Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle.
Okay, assalamualaikum and a very good morning to all of you. Alright, so for the first lab we have two exercises. That is exercise A for the DC measurement of the resistance and exercise B for AC measurement of the resistance. Alright, so we proceed to activity 1A. Alright, so for the activity 1A, we need to build the circuit based on the figure 1.1 with DC voltage supply. The value is 10 volt. Alright, this is a DC supply, and then this is a resistor, and then we got two multimeter here to measure the current and the voltage. Alright, so don't forget to change the voltmeter resistance because of the task need us to change the voltmeter resistance, change to 10 kilo ohm or 10,000 ohm. Alright, click OK, and also this, change the voltmeter resistance 10 kilometer ohm or 10,000 ohms. Alright, so what we're going to do now, we just run the simulation and then you will get the answer. You will get the measurement. This is 101 milliampere for the current and the 10 volt for the voltage. Alright, so stop the simulation and you change the value of the current, the value of the resistor to 150 ohms. Okay, and then run the simulation back, and then you will get 97.997 milliampere for the current and the 10 volt for the voltage. Alright, so stop the simulation and then change it to 200 ohms. Okay, click OK, and then you just run the simulation back, and then you will get 51 milliampere for the current and then 10 volt for the voltage. Alright, stop the simulation and then change it to 300 ohms. Okay, and then you will run the simulation, and then you will get 34.333 milliampere for the current, and then for the voltage also 10 volt. Alright, so stop the simulation and then lastly change it to 1000 ohm. Okay, run the simulation and then you will get the result for the current is 11 milliampere for the current and then 10 volt for the voltage. Alright, so that's all for the activity 1A. Alright, so for the activity 2A, we need to connect the circuit based on the figure 1.2. Alright, so we have here DC voltage, that is 10 volt as a value. Alright, so we have the resistor and 2 volt multimeter, that is to measure the voltage and then to measure the current. Alright, so don't forget to change the ammeter resistance based on the instruction that they given in the lab sheet. Change to 15.5 ohms, and also this change the ammeter resistance to 15.5 ohm. Alright, so after that you just run the simulation and then you will get the result. For the voltage is 10 volt, and then for the current you get 86.58 milliampere. Alright, so stop the simulation and then you change the resistor to 150. Okay, and then run the simulation back, and then you will get 10 volt for the voltage and then 60.423 milliampere for the current. Alright, so stop the simulation and then change to 200 ohm. Okay, and then run the simulation and then you will get 10 volt for the voltage and then 46.404 milliampere for the current. Alright, stop the simulation, change the resistor value to 300 ohms. Okay, and then you run the simulation back, and then you get 10 volt for the voltage and then 31.969 for the current. Alright, so stop the simulation and then lastly change it to 1000 ohm for the resistor value. Alright, run the simulation, and then you will get 10 volt for the voltage and then 9.840 milliampere for the current. Alright, so that's all for the activity number 2A. Okay, so for the activity 3, still the DC voltage supply. This use the DC voltage supply, that is 10 volt, and we got the resistor and 2 multimeter. So for the activity 3, we only want the value of the current in this position. Right, so don't forget to change the emitter resistance to 15.5 as the instruction on the lab sheet. Alright, so after that we just run the simulation, and then we will get 89.5 milliampere for the current. Alright, so stop the simulation and then change the value of the resistor to 150. Okay. Alright, so run the simulation, then you will get 60.423 milliampere for current, and then stop the simulation and then change the value of the resistor to 300. Okay. Alright, run the simulation back, and then you will get the answer is 31.969 milliampere for the current. Alright, so that's all for the activity number 3. Okay, for the activity number 4, we still use a DC power supply. This 10 volt of the DC voltage. Alright, so we got 2 multimeter and the resistor, and also don't forget to set the voltmeter resistance to 10 kilo ohm or 10,000 ohms. Right, so this voltmeter resistance change to 10 kilo ohm or 10,000 ohm. Alright, so after that we just need to run the simulation, and then we get 97.997 milliampere for the current, right? And then we get the 10 volt for the voltage here. Alright, so stop the simulation and then change the value of the resistor to 300. Okay, and then start the simulation back, and then we get 34.333 milliampere for the current, and then 10 volt for the voltage here. Alright, so stop the simulation and then change the resistor value to 1000 ohms. Alright, run the simulation, and then you will get 11 milliampere for the current and then 10 volt for the voltage. Alright, so that's all for the activity 4. Alright, so we will proceed to activity 1B. Alright, so for the activity 1B, we need to use AC power supply. So we need to change the voltage RMS to 10 volt and then the frequency to 50 hertz. Alright, as the instruction from the lab sheet. And then we got 2 multimeter, one for the current measurement and then one for the voltage measurement, and then we got the resistor here. Okay. Alright, so for the multimeter, if we want to measure the AC, we need to use this symbol on the multimeter. Right, so before this we use this because of DC measurement, but now we use AC measurement, so we need to use this symbol on the multimeter. Alright, so run the simulation, and then we will get the value of the current is 47.9619 milliampere, and then for the voltage we got 10 volt. Alright, so stop the simulation, change the resistor value to 390. Okay, and then run the simulation back, and then we get the value is 25.641 milliampere for the current and then 10 volt for the voltage. Alright, stop the simulation and then change the value of the resistor to 470. Okay, and then run back the simulation, and then we will get the value of the current is 21.276 milliampere, and then for the voltage is 10 volt. Alright, stop the simulation, change the value of the resistor to 890. Alright, so run the simulation back, and then we will get 11.628 milliampere for the current, and then for the voltage we got 10 volts. Alright, so stop the simulation, and then alright, so that's all for the activity 1B. Okay, so for the activity 2B, we still use the AC power supply, so we need to set the voltage to 50 volt, and then we set the frequency to 50 hertz. Okay, and then we got two resistors here, R1 and R2, and then we got two multimeter to measure the voltage. Alright, so we start the simulation as usually, and then we got, for the first multimeter we got 32.5 volt, and then for the second multimeter we got 17.5 volt. Alright, stop the simulation. Change the value of the resistor to 390 for the first resistor, and then here R2 we change it to 470 ohms, and then run the simulation back. Okay, so we will get, for the first multimeter we get 27.325 volt, and then for the second multimeter we got 22.674 volt. Alright, stop the simulation. Change the value of the resistor. R1 we change it to 470. R2 we change it to 860 ohms. Okay, so we run the simulation, and then we will get the first multimeter we get 32.33 volt, and then for the second is 17.669 volt. Alright, stop the simulation. I change the value of the resistor to 210, and then ohms, and then change the R2 to 860 ohms. Okay, so run the simulation back. Okay, then we will get the first multimeter we get 40.189 volt, and then we get the second multimeter we get 9.813 volt. Alright, so that's all for the activity number 2B. Okay, so for the last activity for our first lab is activity 3B. Okay, so we still use the AC power supply, so we need to set the power voltage, that is 10 volt, and then frequency we set it to 50 hertz, and then we got here 3 multimeter, 2 for measure the current, and then 1 for the voltage. Alright, so and also we got 2 resistor here, R1 and R2. Alright, so run the simulation. Then we'll get the current for the first multimeter we get 47.619 milliampere for the current, and then for the second multimeter we got 25.641 milliampere for the current, and then for the voltage on the third multimeter we got 10 volt. Alright, stop the simulation. Change the value of R1. For R1, change it to 390, and then for the R2 we change it to the 470, and then run the simulation back, and then we will get the value of the current in the first multimeter we got 25.641 milliampere for the current, and the second multimeter we got 21.276 milliampere, and then for the volumeter, for the voltage third multimeter we got 10 volt. Alright, stop the simulation. Change the value of R1 to 470, and then for the R2 we change it to 860. Alright, so run the simulation back, and then we will get the value for the first multimeter we get 21.276 milliampere for the current, and then we will get second multimeter we get 11.628 milliampere for the current, and then for the voltage From the third multimeter we get 10 volt. Stop the simulation and then change the R1 to 210. Alright, so R2 also change it to 890. Alright, so run the simulation back. Okay, so for the first multimeter we got 47.619 milliampere. So, and for the second multimeter we got 11.628 milliampere. And then for the voltage for third multimeter we got 10 volt. Alright, so stop the simulation. Alright, so that's all for our lab. Thank you for watching.